All right, we're getting creative now. Just want to be able to go over this Chapter 10b test with you. So I'm going to scroll through my answer key and then maybe point out a couple of different things along the way. So first page, first one, you want to go ahead and think about the, well, you would use the ratio test, but you know the center of the interval is at 2, so you can really knock out choice C and choice D. So then actually I just tested in the one endpoint that's different to see would that converge or not. You get alternating harmonic, so does converge. Number 2, let's see here, convergent geometric, divergent p-series diverges by the nth term test. Question number 3, took a look at let's see, the p-series conditions versus the geometric series conditions, and this one actually would be in between 2 and -2, but you need the overlap of those. Giving you answer choice C. Looking at number 4, limit comparison test. You want to go ahead and use something that is close to what you really have there. Looking at the next one, we've got our infinite series. The sum of the series is going to be this. First term over 1 minus common ratio, as long as that common ratio gives a value between 1 and -1, and so you need it to be -k for that to happen. There's Claire with her blocks. All right. Which of the following are conditionally convergent? Let's see here. The first one was absolutely, and then the other two are conditionally convergent. And let's see here, a Maclaurin series for f. So first I found the series for f prime using the geometric a over 1 minus r, and then I integrate term by term to get the series for f. All right, this free response, this first one was a little bit of a doozy. Part A, you needed to use arctangent. So you needed to use that trick there where we try to get something squared plus 1 in the denominator to get that arctan. So I multiplied by 1/9 over 1/9 first. Then I did my u sub. And then after having that, I was able to get the correct antiderivative. That was the first point, correct antiderivative, then your limit expression, and then finally the correct answer or something equivalent to that correct answer. You couldn't get part B if you said that the series was going to diverge. You could only get if that one was going to converge. You could have showed by the integral test, the limit comparison test, or direct comparison test. All of those were okay, but integral test was almost risky in case you had part A totally wrong. Then that wasn't the best choice to use part A in part B if it wasn't correct. You did have to state the conditions, right? State the conditions, and so you did have to use this if you wanted to use the integral test. If you wanted to use the direct or limit comparison, you did have to explain your p-series that you compared to and why. Part C, one thing that I noticed a lot of people were looking at is trying to use the alternating series test. You do in fact have an alternating series here, but you always want to check for absolute convergence first, and if you can prove that, there's no need to do the alternating series test. You can just use converges absolutely, and that's exactly what happens here. All right, last one. Let's see here. Part A was worth 3 points, 2 for the second degree Taylor polynomial, and then 1 for the approximation, which you didn't need to simplify, but if you did simplify, had to do correctly. Part B, 5th degree Taylor polynomial for G prime. This time they didn't say, sometimes they've said ignore extra terms. They didn't in this case. You had to have an actual 5th degree Taylor polynomial. So you substitute in f of x cubed to the answer that you had up above, and then you have to take the derivative term by term. 3rd degree Taylor polynomial about x equals 1. Let's see here, x equals 1. Some people forgot to do around x equals 1. A few people chose the derivatives from the table at x equals 0 and had some issues there. And then the last part, our Lagrange error bound. You've got to have this form before you have anything else. So you've got to have this form of the error bound to be able to get that answer point. You don't have to simplify, but if you do simplify, you have to do so correctly. Oh my goodness, baby Claire is so excited by her bucket of